Okay. Oh, by the way, Maria, please check your G apps, okay, and reply my email. So the first presenter will be Kenzie. Okay. You can start. Okay. So Kenzie, you can start in your presentation.
Tes tes. Hmm, did my screen already sharing?
Yes. Yes. Yeah. I can see. I can see your screen.
Okay, hello everybody. My name is Kenzie, and now I'm going to talk about the linear system of linear equation into variables. So basically, it's going to be divided by two. The first one is linear equation and linear inequality. For linear equation, as we all know, we have the equal to symbols, and linear inequality we have the greater to, smaller than, greater equal to, and smaller equal to. For this. And then for the linear equation, for you solving the problem, you can use two methods. The first one is the substitution. The second one is the elimination. So this is the what's the problem looks like. It's basically from my students, from my video. So for this one, I use the elimination method. So basically for elimination method, you want to choose whether you want to eliminate the y first or the x first. And for this case, I choose to eliminate the y first, and then I get the x. After I get the x, I can substitute the x, and I can get the y. And then for this part, I use the substitution method. So for the substitution method, you want to substitute. Oh, what is that? Sub y or x. So you wanna choose one equation. You wanna find the y or find the x, and then you can plug in the y into the other equation, so you can get x, and then you can get the y. So for graphing equation, the linear equation, it's basically you have to find the x-intercept first, and then y-intercept, and then you draw a line. As you know, linear equation is basically a line like this, a straight line. And then move on, we go to the linear inequality. For the linear inequality, I think it's pretty more complicated because you, you have to uh, draw the graph if you want to make sure what the answer. And if the problems give you the symbol like this and this, there's no equal to, no equal to, the graph will be like this. Not and if the equation give you like have the symbol of equal to and equal to, it will be like this. The point will be like a full circle. This is like the circle. The inner part is empty. This is the inequality problems. So it's like a basic one, like you just substitute, move the left to the right, left to the right, and so on, and then you can get the solution right here. And then graphing inequality, it's basically the same step. First one, you can find the x or y intercept, and then for this symbol, the graph will be like this dash because it's not equal to, so it's gonna be dash line. And for this equation, the graph will be like straight line, like the linear equation one. So and now we're gonna try to graph. The first one is like x is smaller than minus 2. So the first one we need to find the y-intercept and x-intercept. So as you can see, we can say in this equation the y-intercept is 0. So we're gonna put like 0. Oh, sorry. Minus 0. So right there, and because it's uh, smaller than, not smaller equal to, so the line will be dash, and then we have to find the part that satisfy this equation. Like like it's basically you find the true one because as you can see we can take 1 point and 1 point from the left and 1 point from the right. So 1 point from the left is minus 3 smaller than minus 2. It's true, right? So basically it's this part is the one that satisfy this equation. The this problem is also the same, but it's just why it's just yes, it's basically the same. And then for this part, yeah, you have to find the x-intercept and y-intercept, and then you find the the part that gonna satisfy this equation, and it's basically the same. All the problems is the same. And for the linear equation one, it's you have to, yes, like I said, you have to find the x-intercept and the y-intercept, and then you just draw a straight line. Yeah, I think that's all for my presentation.
Okay. Thank you, Kenzie.
Yes.
So yeah, so linear equations, as you may know, and I think most of you are already familiar, is a basic system, and I also already explained some of the concept, especially related to the matrix system in the chapter 10. So uh, regarding the graphing the linear equation, I hope you already familiarized, because in the next lesson, the calculus, calculus 1, calculus 2, engineering of math, they are using some equations, some linear equations will be a straight line, and you need to at least imagine how it looks like and how to draw in the graph, okay, in the Cartesian coordinate, okay. And also regarding the inequality, okay, I think Kenzie already mentioned most of. Okay, sorry for the connections. Okay, already fixed. Okay, so yeah, I think that's it for the inequality and also for the linear equation. Okay, the next presenter will be Maria, right? Okay, let's give Maria. Yeah, let yeah, you can prepare first.
Hello, can you hear me, guys?
Yes, yes, you can
Oh,
hear.
okay, okay. Okay, hi. So I'm gonna present now. Let me see. Okay, okay. So do you guys see my screen?
Yeah.
Oh, okay, okay. Okay, hi. I'm Maria, and I'm gonna talk about the parabolas and ellipses. So with the parabolas, I'm gonna be like real quick because another classmates already talk about that. So I'm just gonna like have some points. So first, I'll start with the geometric definition. So the parabolas is the set of all points in the plane that are equidistant from a fixed point F, when we're gonna call it the focus, and a fixed line L, the directrix. And if you saw my video, you see that I explained the whole equation. So this is the standard form that we're gonna use with the parabolas. So this one is x squared, but in the presentation I was not able to put it that way. So this is that. So here we have the equations and graph. If the parabola is in the vertical axis, we're gonna have the vertex, it will be 0, 0. The focus will be 0, p, and directors will be y equals minus p. The part with the focus we have to check, because if it's 0, p, then it's vertical. And here we have the graph. If p is positive, it will be like upwards, and if p is negative, it will be downwards. Then we have if it's horizontal. Here the vertex is the same, 0, 0. The focus this time will be p, 0. And the directors will be x equals minus p. So in the horizontal is y, and in the in the vertical is y, in the horizontal is x. And here if p is positive, it will face to the, which side is this? Right side. And if it's negative, it will be left side. And then we have the lactus rectum and the focal diameter. So the line segment that runs through the focus perpendicular to the axis, here we can see it, with endpoints on the parabola is called the lactus rectum. And its length is the focal diameter of the parabola. Here I put the graph. You can see the lactus rectum and the focal diameter. Then we have a simple example. Here we have to find the focus, directors, and focal diameter of the parabola, and we have the equation. And then we have to sketch the graph. Usually the exercises will look like this. In the notes that I will provide you guys, I put some examples and exercises if you guys want to practice this. It's really simple. So yeah, here we have the equation. Oh, sorry. And we see that, you know, how this is how to solve it. Oh, sorry again. This is how to solve it. And then from here, we can find the directrix. And we just need to find the focus with P. And with that same information, we see that 4P equals 2. That will be the focal diameter here. And here we have the graph. As you see, it's really simple. For the parabolas, the applications, we have that the parabolas have an important property that makes them useful as reflectors for lamps and telescopes. Here I put the graph of how like it goes inside the parabola and it reflects. And it's also used in parabolic antennas, like the huge ones, those, and the parabolic microphones. So parabolas is really useful in engineer, mostly. Now let's go with ellipses. So it's a set of all points in the plane that sum of whose distances from the fixed points F1 and F2 is a constant. So those two fixed points are the fuzzy, and that's the polar focus of the ellipse. Here we see how we get the equation of the ellipses. So I explained a little bit more in the video. I just wanted to put it here because I know it looks like a lot, but it's really simple. So the sum of distance from a point to the fuzzy is 2a. We put it that way, so it's like more simple to solve it, and it's like easier for us to get the final form. So here we have it, and this is how the final form will look. So this is the equation that we're gonna use to solve the ellipses. Yeah, as you can tell, we have the same x, y, but this time we have a and b as well, since that's the the normal equation for an ellipsis. So we just need to find this depending of the problem. So here, to graph y equals 0, we get that x squared equals to a squared, or x equals to plus minus a. So the ellipse crosses the axis at a, 0 and minus a, 0. So these points, a, 0 and minus a, 0, are the vertices. And this, for x, will be the major axis, joins the segment of these points. So these ones, the x, is the major axis, and the length is 2a. To graph x equals 0, we get the y squared equals to b squared, or x equals plus minus b. And the ellipsis crosses the axis. Oh, well, I think here I have a typo. Here is y, sorry. In the x equals plus minus b, it's supposed to be y equals plus minus b. So the ellipsis crosses the axis as b comma 0 and minus b comma 0. So these ones, the y, are the minor axis, and the length is 2b. So here we see the differences between if the major axes are horizontal or vertical. So here we have to remember that A will be always major. It will be then B and 0. So here we see the equation A will be x squared over a squared plus y squared over b squared equals 1. And in the other equation, we see that b squared is plus a square, so it changed because, for example, if we have um this side in the left side, it's, for example, 1 over 5, and the plus 2 over 7, then remember the a always have to be larger than b, so we have to exchange that. Okay, just have to remember that. So here the vertices for a will be plus minus a comma 0, and for the ellipsis b will be 0 comma plus minus a. And here I put the examples of the ellipses so you can see which one is which. For the major axis, if it's horizontal, the length is 2a, and this one for the V, it's vertical, and the length is 2a also because it's the major axis. And the minor axis, if it's vertical, the length is 2b, and here it's horizontal for the B1, and the length is 2b. For the fuzzy, we have this equation, which is c squared equals a squared plus b squared. That's the equation that we will use if the problem says, oh, find the fuzzy of the ellipsis, blah, blah. If they give the equation, or yeah, if they give us the values. And for the a, which is remember this equation, which it's a plus b, it's plus minus c comma 0, and for the b plus a will be 0 comma plus minus c. I know it sounds a little bit confusing, but now that we see the examples, it will be a little bit easier to remember. So the first example, we have the equation. In this example, they provide the equation, and we need to find the fuzzy, vertices, and the lengths of the major and minor axes. And we have to sketch the graph. So for the sketching, it's like just roughly, like the ellipses, we don't know if it's exactly like that, but it's like the idea just is easier for us to see how it will look. So here they give us this. This is a 9, by the way. I know my numbers are pretty ugly, but this one is a 9 and the other one is a 4. So here we have a squared equals 9 and b squared equals 4. So here, remember to find the fuzzy, we use the previous equation, which is c squared equals a squared minus b squared. And we just change the value. Since we already have the numbers, we just put it there, and we get plus minus a square root of 5. So that would be the fuzzy. And then we express it like this. I put it in the right side. Here, fuzzy is plus minus a square root of 5 comma 0. And okay, so here to find a, we just solve like this. So square root, it's 3. And then remember that the vertices is plus minus a here. So we see that is plus minus 3. And then for the major one, it's just multiply 2a and 2b, and we get it. So pretty simple. So now we have the other example. In this example, they provide the vertices and the fuzzy, but we need to find the equation. So in this case, we use the values that they provided to see if it's horizontal or vertical. So here we can see that is plus minus a comma 0. So that means that is horizontal. The major axis is horizontal. And with that, we know which formula we need to follow. So here we also have the fuzzy, and we see that c equals to 2. So we have a, c, and we need to find b. So we only use the fuzzy equation to find b. Pretty simple. We just change the values. and we get the equation which I put here. And this is how roughly the ellipses will look like. So yeah, now we have the eccentricity of an ellipse. So for the ellipse x squared over a squared plus y squared over b squared equals 1, or the other one, which is x squared over b squared plus y squared over a squared equals 1, with always a being major than b and 0. The eccentricity E is the number. Here we have the equation E equals C over A. And it will follow that C will be equal to a square root of A squared minus B squared. Here, I was not able to put the A squared minus B squared in the square root. So, but yeah, it is like over both. Yeah. And we see that the eccentricity of every ellipsis, sorry, there's a typo here also. But yeah, the eccentricity of every ellipsis satisfies that 0, um yeah, it will be larger, the E will be larger than 0, but it will be less than 1. So we know that. And this is how it will look. So if it's closer than if it's closer to 1, sorry, it will look like a little bit flatter. And if it's closer to 0, it will look almost like a perfect circle. Okay, that will help us in the, like, when we sketch the graphic. So here we have a simple example. So we have to find the equation with the fuzzy 0 comma plus minus 8, and the eccentricity is this one. They provide the eccentricity, and you just need to sketch the graph. So we have the equation E equals to Z over A, and that will be, so we have A, which is 5, and we have C, which is 4, based on the equation that they provided. So we just cross multiply here to solve, because we have this. Okay, so yeah, sorry, I got confused, but yeah. And we just solve by this. I know it's like a little bit long. No, it's not long, but you just need to check the values that they provided in order to find it. And yeah, here we found that the fuzzy is this. In C we have C, and we choose exchange because E equals to C over A. So as this is E, so we just equal this thing, which 4 over 5 equals A, 8 over A. Yeah, and we just find A. And here we need to find, since we have A, we have C, we have A, we need to find B. So we just use the fuzzy equation to find B. And we just graph we just sketch the ellipses. Yeah, and here we have the equation, which is x squared over 36 plus y squared over 100. And you can see we use the one here for the fuzzy. You can see that the right, well, x will be over b and y will be over a. I know my explanations are not that great, but that's why I'm not a teacher. Yeah, sorry. Yeah, with the application of ellipses, we have a medical device called the lithotripter. I don't know if that's pronounced correctly, but yeah, uses an elliptical like reflectors to break up the kidney stones by generating sound waves. That's pretty interesting. Also, some buildings like the theaters, some of them called whispering chambers, are designed with elliptical domes so that the person whispering at the focus can easily be heard by someone standing at the other focus. So this occurs because of the acoustic properties of an ellipse. So that's very interesting. Like the ellipses also can use to build different structures, so the sound can like move better. But yeah, that will be it. I hope you guys understood everything. Yeah, I don't know if you guys have any question.
Yeah, thank you, Maria.
Welcome.
Yeah. So we have two presenters today. First is Kenzie, second one is Maria. Let's start with the Kenzie first for the discussion part. Okay, for
Okay.
Kenzie, any question for Kenzie for the students? Okay, there's a question from Ardian and Hans. You can try to answer, Kenzie. Okay, Kenzie is. Can you hear me, Kenzie? It seems Kenzie is not around, or maybe not listening. Um, let's turn to Maria. Okay. So, any questions for Maria? I think the part uh, from Maria presentation is interesting. Okay, Jonathan, why the uncertainty cannot be less than 0 or more than 1?
Oh, so isn't that because of the number E? Like the that one, like I tried to investigate, and I actually I forgot because I didn't like my presentation like a long time ago. But yeah, is it because of the number E? Like the I'm sorry, so I will need your help with that because I really tried to understand that part as well, but like the level of people explaining that in the internet was like above my understanding.
Okay, Kenzie, wait for a second. I will help Maria first. Okay, why the eccentricity cannot be less than 0 or more than 1? So, eccentricity means it's a ratio between how the elliptical shape, the how to say that, the it's a ratio between the major axis, right?
Mm,
So, if you got like more than one, okay, you imagine you are stretching the ellipse. Okay, if it is like more than one, it will be not an ellipse, it will be like a line if you press down. Okay, if you imagine
yeah,
that. Okay,
yeah. Okay, thank
and
you.
and yeah, similarly, if you are going to have like going to be a 0, it will be a circle, and that if you have a circle, then it's not an ellipse. That's as simply as that. Okay? So eccentricity
Also,
is just a ratio, a proportional ratio between the number C and A, right? The number C and
mm,
A, the focus and the axis, the major axis. Okay.
okay, thank you.
Yeah. Okay, Kenzie, can you discuss with the answer the discussion with from Ardian and Hans? Okay.
Okay. Okay. The first one, Ardian called me and asked the example of the application in real life. Okay. I think for like for the real life, I don't think there's really much application from this one. I still don't know, but for me, I think there's not much. But maybe Prof. Iman can tell me more about this. And Hans asks about, are there any methods other than substitution and elimination? If so, what are they? For if the maybe because I think my presentation is not perfect enough. So maybe for the if you have like the quadratic uh, problems, you can use the what is it called? Factorize the problem, the equation, and then you can get the x and y intercept. Yes, I think that's all, Prof.
Okay. For okay for the linear equations in real life, actually there's a lot of applications. Like if you want to, for example, the some simple trading. Okay, like in a buy and sell, or even in the stocks investment. If they have the simple equations, probably they will use the linear equation if the trends is linear. Okay, and also maybe forecasting, weather forecasting. Sometimes they can still use the linear equation if it is it's a simple equations. Also to take the economic, like in industry, sometimes if uh, the equation is simple enough, it will be using the linear equation. But for engineers, I think mostly linear equation will be the basic foundation for linear algebra. Linear algebra is basic foundations of most of the computers programming. Okay, so yeah, if you remember the binary system in computers, that's basically based on linear equations, solving linear equations. Okay, and writing in a matrix system, right? And simply most of the codings, like in robotics, AI, and you name it, they are based on linear equations, solving linear equations. Okay, like system logic, 1-0 binary system. How to design that? Basically, that is from linear equation. So you can check it out, and you will see that it will be based on linear algebra. Okay. Okay. And are there any methods other than substitution and eliminations? If you combine with the quadratic, of course, quadratic is not linear. Okay, it's not linear equation, so that will be different. So substitution elimination is basically one of the basic concept for solving linear equation problem. The other way, I think I've told you before, you can use the row echelon form, the Gaussian method. Okay, the Gaussian method. Uh, if you think it's still confusing, you will see later on, okay, in other courses. So I believe it's better if you try to understand the Gaussian method and using it to solve a system of equations. Okay, so if you have more than two, maybe three, maybe four, maybe five, you can also try to make the Gaussian method. Okay, you can use the Gaussian method. Okay. Candlestick. Candlestick in what do you mean? Candlestick? Candlestick. What do you mean by the candlestick? Not sure. Oh, the chart, or do you mean the chart? Candlestick chart. Oh yeah, 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 yeah. The chart, right? Yeah, yeah. If this is simple enough, sometimes they will use the linear equations. And Jordan, you asking what's the interesting part for you from this topic? You asked to Kenzie or Maria, or maybe both of them can answer. So Kenzie, can you answer what's the interesting part?
Okay, for me, I think the most interesting part is I think it's the inequality system because it's the most for me it's the most challenging one in in this in this what in this topics because the linear equality is like it's like it's basic like you just elimination or substitution move from left to the right, but for the inequality part you have to like you have to draw the graph, you have to find the point, you have to what and find well, draw the line. What is it called? I forgot the line.
Line
And
numbers. Yeah.
yes, yes, line numbers. And if you want to uh, draw the inequality graph, we have to pay attention about the symbols and whether it's a dash line or it's a full line and something like that.
Yeah, I think that's also true. So in inequality, you need to be careful where the where you need to draw the line, how to draw the line, and where's the you need to fill in, right? You need to fill in which part. If, is it less or greater? You need to be careful on. Okay, and I think this will be the end for today's lesson. And for Maria's part, okay, please remember, okay, that is about the conic sections. Okay, conic sections. We will meet those conic sections a little part of conic sections in next semester in calculus 2. So I hope you can familiarize with the parabola, ellipse, and also I need you all to check the hyperbola. Okay, the equation is similar to ellipse. You just change the positive with negative. No QR code. I will just check your name here because we are just a few students, right? So that's okay for the QR code. So that's it for today. So remember, conic sections, parabola, ellipse, hyperbola. You need to check it out. And if we have time, I will give you just maybe 10 to 15 minute summary later if we have time. So we still have several presentations from Helen, Hans, and Jordan. Hopefully next week we will have those three in Tuesday class, and maybe Wednesday class. I can give some summary, and maybe we can prepare for your final report. Okay, final report. I will put the information maybe this week for final report. So please check the Google Classroom, and maybe you can prepare the final report and maybe submit it around the first week of January before the final exam started. And maybe we will have some break on January, and then we will have a final exam. I will give you the confirmation for the schedule. Okay. So thank you for joining today's class, and see you next week. Okay. The final report it's in, I think not in video form. I think it's better in written report. You can prepare the digital files. Okay. Digital files is probably better. Okay. Okay. See you around.